In this topic, we are going to learn about trigonometric ratios. Let's start off with a quick recap. Given a right-angled triangle ABC, do you know where is the hypotenuse? Yes, it is the side that is opposite the right angle. Some identify this side by looking for the longest length. We shall call this side C. Let's name the other two sides A and B. The relationship between ABC is given by C squared equals to A squared plus B squared. And we call this the Pythagoras theorem. This theorem can only be applied for right-angled triangles. Let's look at some example. In order to find x, we need to apply the Pythagoras theorem. C squared equals to A squared plus B squared. Do you know the values of C, A, and B? Yes, C is x, and hence we have x squared. For A and B, we can substitute in 6 and 8, and hence we will have A squared plus 6 squared, or 6 squared plus 8 squared. Simplifying, we will have x squared equals to 100. To find x, we need to square roots on both sides. And we will have x equals to 10 centimeters. Let's look at another example. In order to find x, we will need to apply the Pythagoras theorem. C squared equals to A squared plus B squared. Can you identify the values of C, A, and B? Yes, we will have 13 squared equals to x squared plus 5 squared. Simplifying, we will have 169 equals to x squared plus 25. Subtract 25 from both sides, we will end up with 144 equals to x squared. In order to find x, we need to square root on both sides, and we will have x equals to 12 cm. We shall next look at the naming of the sides of a right-angled triangle. Previously, we have already discussed that the length opposite the right angle is called the hypotenuse. For a given angle theta here, the side that is opposite this angle is called, yes, the opposite. And the other side that is next to the angle is called the adjacent. Now let's look at another triangle here, STU. The hypotenuse, once again, is the side that is opposite the right angle. Now, if the given angle is here, do you know where is the opposite? Yes, it is TU. And the other side that is next to it is called the adjacent. It is easy to identify the hypotenuse, opposite, and adjacent sides by first starting off with finding the hypotenuse, then the opposite, and the adjacent. In short, we can name it as HYP, OPP, and ADJ. Given a certain angle theta, the trigonometric ratios is defined by sine theta equals to the opposite over the hypotenuse, cosine theta equals to adjacent over hypotenuse, and tangent theta equals to opposite over adjacent. These trigonometric ratios can help us to find the length and angle of a right-angled triangle. In order to help us to remember the trigonometric ratios, we can look at the first letters here. And we will come up with the acronyms SO, CA, TUA. Whereby SO is sine theta equals to opposite over hypotenuse. CA is cosine theta equals to adjacent over hypotenuse. And TUA is tangent theta equals to opposite over adjacent. As a reminder, trigonometric ratios can only be applied to right-angled triangles. Next, we shall learn how to use the trigonometric functions in a calculator. First, you need to ensure that your calculator is always in degree mode whenever you are using trigonometric functions. can you locate the trigonometric functions on your calculator? You'll see the sine, cosine, and tangent buttons on your calculator. First, let us learn how to evaluate sine 30 degrees. To do that, we must press sine 30, followed by the equal button. And we will have sine 30 degrees equals to 0.5. Next, try to evaluate the following trigonometric ratios. By using the calculator, sine 60 degrees equals to 0.866 rounded off to 3 significant figures. Do you get this answer? Cosine 120 degrees equals to negative 0.5. And tangent 45 degrees equals to 1. From this right-angled triangle PQR, we are asked to evaluate sine theta. First, let us look at the acronyms again. So, ka, tua. For triangle PQR here, do you know where's the hypotenuse side? Yes, it is the side that is opposite the right angle. Given the angle theta here, do you know where is the opposite side? Yes, it is here. And the side that is next to the angle theta is called your adjacent. In order to evaluate sine theta, we need to use sine theta equals to opposite over hypotenuse. We shall now substitute in the opposite length and the hypotenuse, which is 6 over 10. Simplifying, we will have 3 over 5. Next, we are asked to evaluate cosine theta. For cosine theta, we will have adjacent over hypotenuse. Substituting in the values, we will have 8 over 10. And simplifying, we will have 4 over 5. Finally, let us evaluate the trigonometric ratios tangent theta. For tangent theta, we will have opposite over adjacent. And we will have 6 over 8, which is equals to 3 over 4. Now, what's happened if the given angle is sine angle QPR, which is here? In this case, the hypotenuse is still the side that is opposite the right angle, but the opposite side is now, yes, QR, and the adjacent side is PQ. So, in order to evaluate sine angle QPR, we will need opposite over hypotenuse. And we will have 8 over 10, which is 4 over 5. For cosine angle QPR, we will need the adjacent and the hypotenuse. And we will have 6 over 10, which simplifies to 3 over 5. Finally, for tangent angle QPR, we will need the opposite and the adjacent side. Substituting in the values, we will have 8 over 6, which will give us 4 over 3. Now, let us use the trigonometric ratios to help us to find angles and length of a right-angled triangle. In this right-angled triangle, LMN, we are asked to find the length MN. Now, given the angle 30 degrees, can you identify which is the hypotenuse, opposite and adjacent side? Yes, the 24 cm here is the hypotenuse, and MN here is the opposite side. Now, we do not need to label this side here because we are not using this side, neither are we given the length. So, using opposite and hypotenuse, can you identify which trigonometric ratio we should use? Yes, we should use sine theta equals to opposite over hypotenuse. And let's now substitute in the values now. Theta is equals to 30 degrees. And on the left hand side, we will have sine 30 degrees. On the right hand side, the opposite is MN, while the hypotenuse is 24. To solve this, we need to multiply 24 on both sides. And we will have MN equals to 12 cm. Here, we have used the trigonometric ratios to help us to find the length of a right-angled triangle. Next, let us find the length YZ. Given the angle 75 degrees here, can you identify where is the hypotenuse, opposite and adjacent sides? Yes, XY here is the opposite side, while YZ here is the adjacent side. We do not need to label this side here because we are neither finding it nor are we given this length here. Using opposite and adjacent, which trigonometric ratio will you use? Yes, we will use tangent theta equals to opposite over adjacent. Now let's substitute in the values. On the left hand side we will have tangent 75 degrees. And on the right hand side we will have 18 over YZ. To solve this equation, we need to multiply YZ on both sides. And we will have YZ tangent 75 degrees equals to 18. To find YZ, we will divide both sides by tangent 75 degrees. And we will end up with YZ equals to 4.82 centimeters rounded off to 3 significant figures. Now let us find angle HJI. If HJI is the angle that we are finding, can you identify which side is this and which side is this? Yes, IJ is the hypotenuse while HJ is the adjacent side. We are not going to use the length HI, nor are we given the length here, so there's no need to label this length. Can you identify which trigonometric ratio uses adjacent and hypotenuse? Yes, it is cosine theta. Substituting in the values, we will have cosine angle HJI equals to 4.2 over 9.1. In order to find angle HJI, we will need to inverse cosine on both sides. And angle HJI will be equals to the inverse cosine of 4.2 over 9.1. By pressing the calculator, we will have angle HJI equals to 62.5 degrees rounded off to 1 decimal place. Next, we shall look at how to use the calculator to help us to find this answer here. We'll start off by learning how to press inverse cosine. To do so, we need to first press the second function or the shift button, followed by the cosine button. And you will get inverse cosine. Likewise, to find inverse sine, we'll just press second function sine. For inverse tangent, we will press second function tangent. Next, we shall press the bracket, followed by 4.2 over 9.1 close bracket. And we will press equal to get 62.5 degrees, rounded off to 1 decimal place. In summary, the acronym SOHCAHTOA can help us to remember the trigonometric ratios, which is sine theta equals to opposite over hypotenuse, cosine theta equals to adjacent over hypotenuse, and tangent theta is equals to opposite over adjacent. Once again, trigonometric ratios can only be applied to right-angled triangles. And in order to find theta here, we need to inverse sine on both sides to give us theta equals to the inverse sine of opposite over hypotenuse, and likewise for cosine and tangent. Do refer to the previous part again on how to press the calculator to use the inverse trigo functions. That's all for this topic.